So let's talk about bone growth and development. If you haven't already, I strongly encourage you to go through the cartilage slides and watch that video because it's going to be very, very relevant to what we're going to talk about, and it sets a pretty good foundation. It sets the stage very nicely for this series of slides. So you're conceived, cells divide, and eventually they start to organize into discrete sections. What is going to become your bony skeleton all starts off as chondrocytes and specifically as hyaline cartilage. So in utero, all hyaline cartilage. And you do have that capsule. So eventually you're going to need to ossify that skeleton, right? You can't just be born as one big cartilage skeleton. Like we said with the bones lecture, if your skeleton was made up of nothing but that collagen without the hydroxyapatite impregnating it, you'd be sort of Gumby-like and you wouldn't be able to hold yourself up against gravity. In utero, that doesn't matter so much, but when you're out in the world walking around or crawling or trying to lift your head, that does matter. So you start off as hyaline cartilage and you have that perichondrial sac surrounding it right here, first couple months in utero. Slowly through gestation, all the way up through adolescence, you start to ossify. We say all the way up through adolescence because by the time you're born, you are quite ossified. You have an awful lot of hardness to your bones, but you are still growing. And bone tissue being super rigid doesn't really lend itself to expansion exactly. So the cartilage is going to have to grow first. So you're going to have to, and then that will be ossified. So you're going to want to preserve some collagen in the skeleton even after you're born, all the way up through when you're done growing. All the bones, that should say below, below the skull are formed by the process we're going to go through here, except for the clavicle. The clavicle is fairly well ossified, actually, even by the time you're born. So here's our steps. First, so you start off as all hyaline cartilage, right? The hyaline cartilage has to start be broken down and replaced with bone tissue. That's really the process of ossification. Hyaline cartilage gets broken down and gets replaced with bone tissue. Chondrocytes are replaced with osteocytes. That collagen matrix is going to be impregnated with hydroxyapatite, etc. So this kind of growth can't occur without a blood supply, right? So first things first, you're going to grow some blood vessels into it. And you can see the blood vessels go right up through into the middle. This would be the hardest place for nutrients to reach if you were providing vasculature outside in, right? So this is kind of a smart arrangement. You get the blood vessels in the middle, they can diffuse out, everything can get better access that way. The perichondrium is quickly replaced with periosteum, again, extremely similar type of membrane. The periosteum forms a bone collar around the diaphysis of the hyaline quote-unquote bone. All of this is really happening in the first, 2 to 3 months gestation. So right up through here, more or less. So you can see the blood vessels had gone into the middle, and then the yellow on the outside is sort of your bony collar, and it looks like it's just growing on the sides, but really it's sort of forming like all around. Okay? So you have blood vessels that grow in, perichondrium is replaced with periosteum, super similar tissue, only slightly different. And then you start to form this bone collar around the shaft. You should say diaphysis though, around the diaphysis of the hyaline, quote unquote, bone. So we've started ossification in the middle. Next, the center of the diaphysis calcifies and develops into the medullary cavity. You have that blood supply in the middle of the bone, right? So you can start converting things there too. You've got a collar formed on the outside, And you're going to start ossifying on the inside too. Over here, you can see this sort of a little more clearly. It's more advanced in this slide, but into childhood, but you can sort of see how there's a different tissue in the middle here than on the outside. So we've got ossification happening on the outside. We've got ossification happening on the inside. Okay? Remember, the medullary cavity is the hollow center of long bones. So this process is really referring mostly to long bone growth, right? Non-long bone growth follows a similar trajectory, but minus the medullary cavity parts, okay? And also remember, that's not actually hollow, it's filled with mostly yellow marrow. The blood vessels will then infiltrate into the medullary cavity. So you had the blood vessels in the middle of the cavity here. I'm going to draw a different sort of a bone. So there's your cartoony, unrealistic long bone. You formed a bony collar around the whole outside. You've started to form, you had blood vessels that were coming in. I know blue isn't the best color for this, but you had blood vessels kind of branching in like this, and then they laid down bony tissue of the medullary cavity. And then for number 5, blood vessels infiltrate through to the medullary cavity, so they'll extend themselves into the middle here. Okay? Periosteal bone. What's periosteal bone, you think? Yeah, exactly. It's going to be the bone that's around the outside, basically wherever you would find periosteum. That's going to start to infiltrate the ends of the bones. The epiphyses we haven't talked about yet, right? It's all been diaphysis. So that periosteal bone is going to infiltrate the ends of the bones and turn cartilage into spongy bone. So you see you had some periosteum here. That was one of the earlier things that happened, right? Perichondrium turned into periosteum. So that's going to kind of come and fill the ends with spongy bone. Remember that spongy bone doesn't have a big open hollow cavity, but it has a lot of small cavities, a lot of small pores. Those are ultimately going to be filled with red marrow, hematopoietic stem cells that are they're blood-forming stem cells. They're going to turn into red blood cells and white blood cells, and that's we call red marrow. The diaphysis elongates. The cavity in the middle becomes the medullary cavity officially, so we're going to create some space in here between the epiphyses and the end of the medullary cavity. Now the medullary cavity is really its own discrete thing. And you've got a space between the spongy bone epiphyses and the hollow medullary cavity, right here and right here. Okay? You can see in this first picture for childhood, this is a lot like how your bones would look when you're born. So you've got the white stuff is all cartilage. You got a lot of that. You've got some perichondrium and ossification happening along the shaft. You have a discrete medullary cavity in the middle. The spongy bone forming at the ends are towards the ends, and you've got this space between them. Okay? Hopefully you're with me so far. Okay, erase that too. So now you're born, and it behooves you to turn some of that squidgy collagen cartilage, doesn't hold up super well against gravity, into more bone, right? So as you grow through childhood, the diaphysis is going to elongate, and the epiphyses are going to harden, so that eventually, I'm going to use blue for this because there's a lot of orange and stuff, So eventually, by the time you're a teenager, it's going to look more like this, or even an older child, just not quite as long. And what's going to happen there is you'll find that you have growth at specific areas that elongates the bone while the rest of it's hardening in between. So the epiphyses then will fully harden, and the hyaline cartilage is only left as articular cartilage at the epiphyseal plate. So you still have, you see this part of cartilage right here? That's effectively, it's not shown well in this next illustration, but that's effectively going to be retained right there. And you have the epiphyseal plate, which is what your cartilage growth plate through childhood, but that's going to ossify too and turn into a pretty visible scar. That's only going to ossify completely once you are done growing, though. So that's kind of the last thing to actually harden. The main exception to this is your facial bones. Your facial bones actually continue to grow your whole life. And some of your cartilage, your facial cartilage does too. You ever notice when you look at a picture of somebody when they're old, when they're young, their nose seems a lot bigger, when they're old and their ears seem bigger? They are bigger. They kept growing their whole life. Your cheekbones get, you might see somebody's cheekbones look more prominent and you think, well, their cheeks aren't as full with fat as when they were younger. That's normal, so maybe their cheekbones are more prominent. There's a little of that too, but also their cheekbones are just a little bigger. Your facial bones keep growing your whole life. So I talked about the growth of the epiphyseal plate and how, or the cartilage plate there, and how it's going to ultimately turn into a scar. It's going to ossify. And I also mentioned that cartilage growth plate is where your bones are going to do your long bones are going to do most of their elongation. It's not going to be this uniform process throughout the whole length of the bone. It's going to be in these two discrete spots towards the ends of the bones. So what's happening here is the diaphysis lengthens by pushing against the epiphyseal plate. What does that mean? Cartoony end of a bone here. I'll just draw one end right there. So you've got periosteum around the whole thing. You've got some articular cartilage up top to keep that bone from rubbing on other bones. You have spongy bone, red marrow up here. You've got a cartilage growth plate right here. Right up at the end of the diaphysis, up against the epiphysis. There's going to be several zones, and we'll see a picture of this soon, in this cartilage. The proliferation zone, hypertrophic zone, calcification zone, and ossification zone. And these are going to basically be arranged in layers based on what stage of ossification we're in. And it's a gradual process. It's not like you're going to see super hard and fast lines. It's going to be like a spectrum. So the proliferation zone, if I can zoom in here, nice big cartilage growth plate. And there your epiphysis would be there, and the diaphysis would be there. The proliferation zone is the layer of chondrocytes adjacent to the epiphysis, and they divide super rapidly. So you have chondrocytes like right in here that are dividing. Now, you have periosteum on the outside, right? You have a thin layer of compact bone on the outside. Are your bones growing outwards during this process? No. They can, based on other mechanical stressors, so that they can withstand the force of your muscles pulling on them, but that's kind of a different thing. We're talking about growth through youth through adulthood, long ways growth. So these chondrocytes, when they divide, are going to take up space and push everything else down. So the bottom of this cartilage growth plate is now going to be like that because they've taken up space. Okay? In the hypertrophic zone, chondrocytes enlarge and lacunae enlarge with it. So your chondrocytes that were up here divided, and now the old ones are down here. okay? Think about the same way as with epithelium, where the oldest cells will divide and then sort of push stuff back up towards the surface, so that you have the newest cells kind of like on the bottom and the old cells get pushed up towards the surface and eventually die. In this case, you have the chondrocytes, which are nice and young up here, and they get older as they move down, away from the epiphysis effectively. So your chondrocytes start to get bigger, and the lacunae around it also gets bigger. So this had a teeny little lacunae. This chondrocyte has a big old lacuna. I'm just going to draw a couple for the sake of time. In the calcification zone, which will be a little further down, okay, like right in there or so we'll say. I'm going to erase that for space. The chondrocytes die, but you still have the lacuna. Okay? The chondrocytes die and leave gaps. They also leave calcified spikes. Okay? So you sort of have this like where you had chondrocytes laying down collagen, and they've started to become a little bit ossified. But they're not really organized or anything yet. It's just sort of a bunch of bony-like spikes. And then finally, the ossification zone towards that's less distal, that's more proximal, I guess, in the bone, that's closer to the, further away from the end. New bone forms within the spikes, so you have some sort of organization. So there's those lacunae. Those spikes become more bony. Okay, and remember you have this sort of growth ring pattern to them. You start to see that sort of organization. Newborn forms within the spikes. Holes left by dead chondrocytes invaded by marrow forming elements. So you have these open holes that used to have a chondrocyte, but now the chondrocytes are dead and gone. You have a lot of vasculature in this area, right? Or at least embedded into the perichondrium and throughout the already ossified bone. So you'll have blood vessels that sort of move close enough so that bone marrow forming elements, bony stem cells, blood stem cells can move their way in. Once that happens, osteoclasts will move in and break down those spikes. Osteoblasts will take the broken down elements and turn them into trabeculi. So you'll have sorry, I clicked that I clicked to the next slide again on accident. So you'll have trabeculi being formed, and ultimately that's going to be ossified and organized. The epiphyseal plate will fully ossify once the person's done growing. There's no more longwise growth after that, but you can grow appositionally or wider in response to mechanical stress. So this diagram, what you see right here, shows the process of appositional growth. You have blood vessels embedded into the periosteum, right? So here's your periosteum. In all these pictures, it doesn't stand out, so I'm just outlining all of them. Okay, you have the periosteal blood vessels. The periosteum is the outsidemost layer of on your bones. It's not bone tissue, but it's the outermost layer on your bones. And your muscles, the tendons of your muscles, ultimately merge, like the ends of those fibers merge with the periosteum. They're made of the same types of collagen tissue as one another. So they merge together, and you have all those Sharpie fibers that are deep to the periosteum that hold that periosteum onto the bone itself, the compact bone. So you contract a muscle, let's say with a lot of force, you're picking up something super heavy. Your muscle's contracting, so it's pulling on the tendon. The tendon is attached to the periosteum, so it pulls on the periosteum. The periosteum doesn't really have any give because it's latched onto the underlying bone by these Sharpey's fibers. But when you have this tension pulling on the Sharpey's fibers, the bone cells that are also attached to them can read that tension and say, ooh, if we don't start building more bone mass and we keep encountering this kind of force, we're going to break. We need to start building bone here. So you have this stress that's going to be pulling outward on the periosteum. And what you'll see is your osteocytes. So we're going to kind of go from here to there, to there, to there, okay? You're going to find that the bone cells will sort of grow up around any given capillary, any given blood vessel we're talking about. So it sort of entombs this capillary a little bit. When each osteoblast entombs itself with osteoid and hydroxyapatite, then that osteoblast becomes an osteocyte too. So you're going to be growing upwards and outwards, surrounding and entombing the blood vessel, while the osteoblasts put down osteoid and entomb themselves as well. Once that blood vessel is surrounded, so we're here now, you have a nice hole with a blood vessel, and probably a nerve with it as well, because nerves and blood vessels usually go hand in hand. The dense irregular connective tissue aspect of this membrane breaks down, and so what you're left with is really just that line of cellular periosteum, the bony stem cells. That is, remember we talked about before that the endosteum and the cellular periosteum are basically the same continuous thing, and this is why the osteon and the central canals are formed when blood vessels in the periosteum are entombed, and then that fibrous part just sort of goes away. So you're still left with that in there, and it's surrounded by more bone mass. The bone is now wider.